586B is the industry standard for wiring straight through cables. Now, what we do on a crossover cable, which means we're going to go from a DTE to a DTE, then we wire one side as a 586A, and then we wire the other side as a 586B. And that's true no matter what your plant is doing. So if the plant you work at wires everything A, uh, then I don't know, then you still do, if you're doing a crossover cable, you still do a 586B on one side and a 586A on the other. But I think it's in our networking slide. I hope so. As soon as it comes up, and then
I got the color code right here.
I'll bring it up so everybody. Who is that?
Crow.
Oh,
It's blue.
so Christian, what's the color code?
It's brown, brown, white, green, green, white, blue, blue, white, orange, orange, white.
We go from pin one. Pin one's on the left.
Oh yeah, I'm going backwards.
Yeah, you're going backwards. So this is a straight through cable. Let's see if we can see the color code. If I can get it focusing in.
That's what? Orange, white, orange,
Yeah.
green, white, blue, blue, white, green,
Brown, white, brown.
brown, white, brown.
Yeah.
I had to make enough of them for you, Rich.
I'll make straight through cables. Yeah, I'll make straight through cables because we're hooking them up to the outlets on the wall. So if we look a straight through cable, you can tell, and then we turn our tester on, and you can set it up to go automatic, then it just goes straight down the line. Except for this one right here, that's ground. So that would true if we were using a shielded twisted pair. So this is UTP cable, which is unshielded twisted pair. So out in your company, odds are if you're using Ethernet IP or whether you're using Profinet, they both use connection right here. Then yours should come on this side right here. So just about every industry runs a shielded twisted pair in their company. By the way, my camera's not doing a good. What color does that look like? It's actually red. Now, crossover cable is going to be real weird because it crosses over, and this is just a pattern that you would have to learn. There's a crossover cable. So this one, here's pin one. It's orange, white, orange. And then when I come up and look at this one and turn it over to pin one, it's green, white, green, if y'all can see it. We're not doing a real good job on our, but what you do after a while, when you made 100 of these, you would come in and you would learn the pattern. So we'll step through it. I'm going to step through it. So here would be orange, white going to green, white, right? And then it jumps. So this would be a pattern, and then this would be blue, white, blue, and then it swaps over again. And oh, sorry, my box is having a problem. This one right here should be on. It was on a while ago. Let's see if I can get it to come on. Oh, I saw it. Yeah, there it is. Even if this one don't come on, this won't have any problem with the cable because of I get it to come on. So there. If it don't come on, the brown white and the blue white are not normally used. Those are up to the company if they decide to use that. I think I told y'all about our phone system at the college. We're using what they call voice over IP now, which means we're actually our office phones are actually through the internet. So what they're doing is they're powering up the phone, in which pair they're using. I don't know if they're using brown, white, brown, or they're using blue, white, blue, but the power actually comes through the jack. And some of the jacks wasn't wired right, so those people have to have a brick that they plug into the tube, or a little power supply they plug into the power outlet to make it work. So this is a crossover cable. And like I said, after a while, you would get used to it. And once you learned it, you would be able to tell it. But what's nice about the breakout, the actual cable tester, it tells you you have continuity in your cable, but it doesn't tell you if it will maintain the speeds that the cable's supposed to maintain. That would be a lot more. I think they call them ODPs or something like that. I have to look them up. But that would be test equipment that you would hook up if you was having problems with speed problems on your network. And of course, what's critical and what people don't understand is how far you can get the cable out of the twist. So basically, it should only be out of the twist right here. So we're looking at maybe a 1/4 inch. We can have that out of the twist and still maintain the integrity of the cable as far as how fast it is. So okay? So here.
Yeah, are you recording?
So I hope so. Yeah. Now that's the problem. So the problem is that I can't tell if it's recording or not when I have my PowerPoints up there or my camera full screen. So this is the cable. I like this cable strip. I like this cable. This is a strip tool. And so it's got 3 units to it. It's got this guy here that actually cuts the cable. It's got this right here that'll strip the jacket. And stripping the jacket's critical because we don't want to nick the wires. And then this right here is the actual crimp tool. So you can actually see the little blades. I don't know if you can or not. That pushes the pins into the cable. So the RJ45 connector, when we insert it in there, then this guy right here is the one that comes in and actually pushes the pins into the cable and causes it to crimp. Now I wish I had the ones that Scotty was talking about, where you can actually leave it stripped a long distance and actually push it through and then cut the cable off when you get out there. Like I said, I've never seen those, but I can understand that. So what we normally do is we come up here and I strip off around 2 inches. We just take it and spin it around. And it's not supposed to go all the way through the jacket. And then what you could do is you have to break it. And then what we don't want it to do is we don't want it to actually pierce any of these inside insulators in there. And then we pull it off. This is the strength member. I don't have my knife with me. I need to cut that off. Let me find my cutters, guys. Let me pause the lecture for a little while. So if you're gonna pull the cable, first of all, if you're gonna pull the cable across the ceiling or something, you want to pull it by the strength member, right? So what you do is you still strip it, and then when you do it, you wrap it around your whatever you're pulling it with, because you want to make sure the strength member is in there. So right now we're gonna clip this off. Then what we do is we'll come up here and we'll untwist the wires. So let me know if I get out of the way outside the camera. And then we'll do this. We'll do this one to B. Now, why you strip off about 2 inches is so you can get enough room to arrange the wires and also try to get the twist out of that back to the jacket. So what I normally do is use the crimper, and the crimp tool, and just pull this across there and try to get all the twist out of the cable that we're not using. We're going to cut most of this off. Okay, so what we're gonna do is we're gonna arrange it from here. The M1 is on the left, right? So we're gonna arrange it from here. So I'm gonna do a B. What we have over on that side.
Wait, I'm trying to find the. Oh,
Waiting.
I'm trying to find the diagram so I can follow along better.
Yeah.
Do you know which one it's under?
Let me go ahead and break this down. I think I was bringing my PowerPoints up when we
Yeah, I wanted to have it pulled up so I could like learn better because like I actually don't know the coding yet, and I need to learn that well.
Yeah, if you're going to build a bunch of
For
cables,
the
or you're going to work at a place that in Ethernet IP, of course, and the problem is, like I said, you can buy pre-built cables, but they might be way too long or they might be way too short. So most places that does this networking, you build the cables yourself, and that way you can build them the right length. Now you want to leave at least the rule of thumb is you need to leave enough slack for at least 2 repairs. Basically, they'll usually leave about 3 or 4 feet on the end, and then they'll loop it in a loop and tape it up, and that way you got a connector that breaks off. Of course, what's the weakest link on these things? The weakest link, and every one of us has been through phones, right? Before everybody started getting cell phones, y'all used the manual phones, and what would break off your cable? A little plastic tab, right?
that little, yeah.
And then this is what actually latches it into the female connector. And if that thing breaks off, then what happens? And that happened to me even the other night. One of my network cables is here, and somebody's telling me you're slowed down, you're lagging, and my network cable, the tab had broke off, and guess what happened? It pulled out, and my computer switched over to my wireless. So that's what happened. So we do have boots, and the only purpose of the boot is to have that little, and some of y'all would first night, and this little old boot, and of course all that does is keep that tab up under there, and it still works. You still can press it, but it keeps that tab. So what happens is this tab will get caught on something, pulling the cables out, and then it'll break the tab off. So all that little plastic boot does, it just covers the back of this tab and keeps that thing from getting caught on stuff. So let's see if it opens. Of course, we're opening this. This might be a little slow because I'm using a virtual private network. So it's actually going from here to, I don't know where the VPN server's at for Lawson State. And then it's got to go back to the servers, our servers. So our file servers are on the Bessemer campus. We have our own file server, file server, and then of course we also have our own domain. So did we talk about domain?
Sure.
No.
I
think we hit on it a little bit, but
yeah, domains.
go ahead.
Domains is a server that's running a special application that where you can manage your network security over. So, like when y'all come into our campus, you log in under that MET STU account, and then you enter a password. Well, you're logging into our domain server, not the college's domain. We're logging into our domain server. Can't open in a dialog box. Has anybody got it open? I don't know. So what we do with that, we can give you, with a domain server, I can determine what rights you get. I can automatically map drives for you or map resources. So if you go and log in with one of our computers, you automatically get access to what we call the student drive, which I don't have it over here on this computer. You get access to what we call the student drive. And then we put stuff in there that it's available on the internet, but it's be a lot faster for you to access it off our domain. So a domain is just a group of computers, and you got one computer that manages the security. Internet uses domains, so that's what they call it a domain name. So when you register your domain, so like Intel is the name of the company, but it's also a registered domain. And so when you log into that company, they have it set so anybody can log in, but I could literally, with that domain server, I could limit who actually accesses my website. So you might go over to some of the Intel sites, and you might not be able to get into some of the places that normal people would have to get into. So it's just a computer running a server application, a domain server application, where you can manage the security of your network. So you set up rights and privileges on there, and so we run our own domain server, and it's called LSCC/MET. The domain I'm on right now is LSCC, which is Lawson Stage domain. So I have to have first of all, I have to have a user account on the server, and then they decide what rights what rights I have. So there's some drives that's shared out there that I don't have access to because they control that through the domain server. But Nancy does. Nancy has access to a lot of stuff I don't. So. It's coming, guys. Can y'all see the PowerPoint? So under the control tab, is it inside this PowerPoint right here? I thought it was. I'm not sure. And that's the problem. If it's not, I'll make sure.
I sent everybody the screen grabs I have for the cables, for the color codes and everything.
Okay, that's good.
Oh, where'd you send it to?
So
I just sent it on Blackboard message.
Yeah, it don't look like mine's going to open up. I don't know what's going on.
Okay.
Just go to your message tab, and you should be able to pull it up.
Yeah, y'all know even when you're on Collaborate,
Yeah, I see it.
Yeah, you still have access to your tab. That's what I like about Collaborate. It opens in a different tab. You can always go back to the other one to use the other features. So what do we got, guys? So I'm gonna turn it this way. I got what? Orange, white, orange. What comes next?
Green, white, blue.
Trying to get the green, white over here. Green, white. And then we go blue. I know the colors are not good for you guys, but it's white, blue,
white, and green.
Blue, white,
And then brown, white,
green, brown, white, brown.
Yeah, it's hard for me to see the colors on the ones that are like the brown, white, and the
Yeah,
blue, white, and the green, white.
Brown, white looks pretty good.
They just have a little stripe on them.
Yeah, they got a little tiny stripe on them. It's real hard to see the blue, white, and the brown, white unless you're actually getting really close to them. So I've got orange, white, orange. And so I might try to order some that Scott and him was talking about. Because the problem is checking it once you get it inside the thing. orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. And then what we'll do is we cut off, I usually cut off about the size of my finger. And this will be, okay, you want to make it flush. We want to make sure we put the thing on there right. So the orange white goes on the left. We're looking at the connector on the pin side. We slide it in there. Remember, I'm doing this.
Rich,
Yeah.
can you say the color code again?
Oh, yeah. I think Kristen sent.
Do you want to say it or send it?
Say it.
Oh,
White.
orange, white, orange,
Okay, so go ahead.
green, white, blue, blue, white, green, brown, white, brown.
Okay, thank you.
And that's the B. And if you was doing a straight through cable, then you'd wire both of them the same way. Double check before I put it in orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Okay. Now what you're going to do is you're going to push it in until this jacket gets under this crimp right here. And I've seen people not do that, and then what happens is your wires are actually holding the connector on there. So we're going to push it in, get it under the crimp. What we want to do when we flip it up is we want to see all these little gold dots down through here. That's going to be the copper dots. That indicates that the cable's in the right distance. And you can actually see where I'm fixing to crimp it. Everybody okay? Then we would slide it in, right? And then we crimp it down. And you should hear a little snap. And then, okay, so that was our cable. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. And that's an A. Are we okay? So what happens if you mess up?
You cut it off and start all over.
You cut it off and start all over. Yeah, you cannot reuse it. Another big thing people will forget to do if they're using these boots, and you got a 50-foot cable, and you forget to put your wad on there first. So if you're going to put the boot on there, you need to do it before you strip the wires. So if you're going to put the boot on there, you need to slide it on there first, and then you can push it back, and then you can strip the wires. Are we okay? You want to do the other side?
Yes.
So we strip off a couple inches. Then we bend it to break it. Oops. And then we double check to make sure we didn't nick the wires. Then I come over here and I'll cut off the string member. I should be disposing of this. And then I come up and twist them out, right? Guess what? The brown wire broke off. Yeah, I did that, guys.
Uh-oh.
I said, huh.
We still can use it if the wires come off?
No, yeah, what I did was
We just got to strip more.
I just cut them back off,
Oh,
cut them all the way off, and I'm going to redo it. But I don't know what I did, guys. Maybe when I was trying to get the jacket out. So the problem I had a while ago is I didn't turn it around for 360 degrees. So what happened is it didn't cut one side. So what I did is I got my little diagonal cutters, and I must have cut the brown wire. So even Rich makes mistakes, right? So I just cut it off, and that's why you got to make sure when you build these things, you don't make them exactly the right length, right? Because if you make them exactly the right length, like the U.S. Steel, when they pulled the multi-conductor cable, man, if you didn't buy cables that had more wires in them than what you needed, then they would really get after you because wires break, and you pull a 300-foot cable that's got 15 wires in it, and you need exactly 15 wires, and one of the wires break, then what do you have to do? We have to re-pull the whole cable. But if you have spares in there, then what they could do is they could just move it over to another wire. Now when we bought cables, we always used cables that had more wires in it than we needed. And you need to make sure you have enough to make repairs on the cable, right? You see what I'm doing there? So what I did, this just gets it out of the wad. It just gets it out of the twist so we can arrange them. Okay, I'm ready. Now we're going to do this one. We did the other one B, so we're going to do this one A, right? Okay, color code, guys. Green, white, green. I'm listening. I built a bunch of these, so I know it, guys. Don't need to. And after a while, once you built a lot, like James said.
Hold on.
Yeah. After James, when he was telling
It's green, white, green.
Green, white, green. Orange, white. Come on.
Orange, white, blue.
Orange, white, blue.
Blue, white, orange.
And yeah, blue, white, orange, and then brown, white, brown.
So orange, white, orange. I'm sorry. Green, white, green. Orange, white, blue. Blue, white, orange, brown, white, brown, right? Right?
Right.
Yeah.
Right.
Yes, and this is for DTE to DTE. Right?
Now this is a DTE to a DTE. If we're going from a DTE to a DCE, or a DCE to another DCE, then we use straight through cables. So we're going from a computer to a PLC, and both of those are DTEs. Now, if I was to go from my computer to a switch, and then from my switch I went to my PLC, then we would use straight through cables. That makes sense? That you got DTEs and DTEs down? Is she still out there?
Oh yeah. Oh yeah.
And now you know about classless IPs. So that guy that was talking to you hadn't been able to go out there and impress him, have you? But she got off.
Nah, when I seen him maybe like 30 minutes. I talked to him the other day though.
Okay. Green, white, green, orange, white, blue, blue, white, green. Blue, white, blue, white, orange, brown, white, brown. Did I say that right?
Yes.
Oh, good.
What was the last three on the B cable?
What was that, Michael?
What's the last three colors on the B cable? The B end, I meant.
The last three colors, the last two are always brown, white, brown.
Brown, white, brown.
Three colors on the B cable would be green, brown, white, brown. So the B cable goes orange, white, orange, green, white, blue, blue, white, green. I'm looking at this cable.
Brown, white.
Orange, white, orange, green, orange, white, orange, green, white, blue, blue, white, green, brown, white, brown.
Okay. Thank you.
And all you're doing is you're switching the orange, white, orange, and the green, white, green. The blues and the blue whites, and the browns and the brown whites stay the same. So the only thing that you're transmitting or receiving are on is the orange, white, the orange, white, orange pair, and the green, white, green pair. The other ones, your blue, white, blue, that's up to your people if they want to use it. If they don't want to use it, they don't. Like I was talking about at our school, they send power for the phones to one of those other pairs. I don't know if it's the brown, white, brown, or if it's the blue, white. If it's the blue, white, blue, I don't know. But at least it's up to the company what they're going to use those other two pairs for. Make sure you put. So I did this, I'd be screwed, right? Pin one to the left, pins up, push it in far enough, push it in really good, right? Because you want it to go all the way to the end. Push it into our, hold it in real good, and then crimp it. I can hear it snap. Okay, so it's our cable, and then of course, if you got to put, so you can see what the jacket does. When the boot, if you slide it on there, then what it does, it covers up the back of that tab and keeps it from getting caught on things. And that's usually what breaks it off, is it gets caught on something and then it bends it up and breaks it. So that's a crossover cable, guys. We'll see if it checks good on our tester. Yep, test good. So our cable is, oh, y'all didn't see it. So like I said, after a while, you would learn this pattern. So the only one that don't come on is this guy right here, and it's ground. And then this is because this is a unshielded twisted pair. If you had a shielded twisted pair, then these two pairs down here should come on. So it looks like we were successful with our crossover cable. Of course, we knew we would, right? All right, guys, I'll take a 15-minute break, okay?
All right.
So this is the mount that we were going to be using. That's my light camera. Let's see if I can get it this way. So we get these by Festo. And we got it approved, by the way, to the trainer that they use to for the Festo N3C certification. Cost around $8,000, and we got this right here approved. This costs around $3,700. So it saved us, and they approved this. So next year, guys, we're going to be offering a certification on Allen Bradley PLC. So we're getting some Compact Logic PLCs, and we'll be using RS Logic 5000. That won't be until next year.
Oh, hell no.
Oh, has he been talking, or are you just setting it up?
Yeah. What?
Oh, you been talking, Rich?
Yeah. I keep forgetting to unpause the thing. So this is
Oops.
EduTrainer from Allen from Festo. This is what they're using on their MPS line. Now, I know y'all saw the ways they mounted the 1500 PLC. This is the way they're mounting it now. And what's nice about this unit is that we can use it for basically any PLC. Got a DIN rail up here, which is what the PLC mounts on. Easy to get on and get off. So we got two options when we mount our PLC. We got these tabs, and we can spring the tabs out. We can spring the tabs out, and then we can screw mount it, or we can leave it like it is, and then we can mount it to a DIN rail. You can see the spotting. So that's the way you can mount it. So you can push it out until they snap, and you can screw mount. And what's nice about the DIN rail, of course, it makes it real easy to take the PLC off and on, especially before repair if you have to ever replace the PLC. We've already set this up. We updated the memory last time, so it already knows this is out here. We went ahead and set it. So what we're going to look at now is basically how we're going to wire this thing up to this DigiFrame. One way we'll wire it, but I don't want to do when you took it to the PLC. We're using these switches right here. And this is what's so neat. We're going to be able to use PLC on this thing that mounts on a DIN rail. And for PLC 1 and PLC 2, then we'll wire it down to switches and we'll wire it up to TICS. But for PLC 3, which is what you're in, PLC is an automated system. We're going to wire it over to this guy. So this guy's got the power supply in it. What we would have done, let me find my screwdriver. And I did have it out here, guys, but no telling where I knocked it around at.
Hello?
I'm sorry, I'm looking for a.
He's looking for a screwdriver.
I don't see.
He said, hello?
Man, it's breaking up real bad on my end. I don't know. They can't even hear me, dude.
Okay, guys, hold on while I find my screwdriver. I'm gonna pause it. We'll look at wiring for the PLC. We'll bring back up that PowerPoint so that. But what we're gonna do is these are the two connectors. One of them is gonna go up to the actual module itself, and then one of them goes up to the control panel. Buy this printer in several different arrangements. So the new ones we're getting is not going to have this section on it over here. Let me get back. The new ones we're going to get is not going to have this section here because we're going to use that strictly for PLC. So to hook up to the MPS line, we have to have this. So it's got a power supply in it. So what we have to do is to run power up to the PLC. That's these two wires right here. So terminate. So they use blue for negative, and they use red for positive on this. And of course, the yellow with the stripe is for that ground. So your PLC in real factories are going to have to be grounded, hooked up to earth ground. Of course, that makes a little more noise and it's acceptable to low electromagnetic. But if we flat, what we would have done, we would have pulled it out and then we would crimp some wires on it and onto the next. So we were using blue. I didn't have any red, but I did have orange wire. That's the wires that I actually put on the terminals. So we put the terminals on there. We were able to crimp the terminals, run them up through here. So these are wires that's going to power up the actual PLC. The power supply runs down the whole back. If we don't have anything on it. It's 24 volt.
Okay, so I said you're crimping the red and the blue into there and then pull it up through, and then you're going to put it to the PL. Okay, I get it.
Yeah. Then once we do that and we establish a common, then the cables that we're going to use that come with the trainer that we're going to wire out. See the power, you can actually see the power supply goes down there. What it's actually rated at, I don't know. I can look up the specifications on it. This is actually what's powering the PLC, and this is what's going to also be powering our module. Now the PLC itself, so here's our arrow pointing in, so this is where we're going to get our DC. It's got a 24 volt outlet. We're not going to use this. We're going to use the power supply that's on the trainer. Usually, the DC output of the PLC is not designed to run a lot of sensors. They don't have a lot of current available to it. This would run switch just fine. So we're just going to use the 24 volt power supply that comes off the edge. We'll have to jump this over here. So on the terminal, L would be your plus, and M would be your minus. Let me get put in. So they don't use for common. They use M. So here, this is the input for an M. So the PLC is running speaking input. So that means so this guy right here, this is the 1214 that we have, runs syncing input and runs sourcing output. So that means if I didn't buy the right PLC and I've got all these sourcing sensors out there and I get a PLC that's sourcing, then those guys are not going to work with each other, right? You understand that? So you have to make sure what your company's doing, because like I told y'all, a company that sells an inductive sensor, 3-wire inductive sensor, probably sells it as a syncing and sells it as a source. So you need to make sure you get.
Hey, excuse me, Rich. This really breaking up real bad, Rich. I'm sorry. I don't know if nobody else, if it's breaking up on anybody else, but every 2 or 3 words is breaking up. I'm on my phone.
Problems hear me?
I think that makes sense.
It's choppy on my end too.
I mean, it's not on mine. I don't know.
Everybody's breaking up for me, so.
Is that better?
Hello?
Yeah, sounds better to me.
Yeah, that's better.
Okay. What I did is I turned the gain up on my Yeti. Can you go back over that again?
Please.
Probably some of it.
Yeah.
I heard M is the ground
Well, M is minus.
or the common.
M is minus and L is plus.
Would be, here it would be. So the PLC can be grounded and not ground these guys right here. Y'all understand that? So this is DC coming up here. That's up to your company. But what you need to understand is over here, M is minus on my supplies. So when I run this up, what I'm going to do is I'm going to hook the blue right here. I'm not going to do it because it'll be hard for me to wire the PLC. And then I'm going to hook, not right there, Rick, up here. I'm going to hook the blue, right here. So this is where the minus of your power supply goes. Whether your PLC is enforcing, this doesn't make any difference. So this is a DC, right? So what does the first DC stand for? So there it is right there. DC, DC, DC. So what does that mean?
All DC.
It means the
DC power, DC input,
DC power, DC input, DC output.
inputs are by DC, and the output is what is 24 volts, guys, and it's pretty stiff. I know it's got to be above at least 20 volts to make this thing work at all. 24 volts standard power supply that we use on these DC PLCs. So what I would do is, here we're not saying ground or anything, we're saying negative. So I would take the blue and I would hook it up to the what? M. And then I would take the what? Then I would take the orange or the red, whichever your company uses, and I would hook it up to the what? I would hook it up to the L. And then you should have a ground, and my ground would go right here. Don't know the difference between a ground and a common, right? So a common is just a common connection. A common doesn't necessarily have to be connected to ground. It all depends on how you do things. So here's where our ground wire would run from our power source. So they make this available right here. So I could have crimped another wire onto this guy. No, they don't even make that available. So I'd had to run a wire from here up to there if I ran ground. Now in your company, we're not going to do that. We're not going to hook up a ground because we're not in a real noisy environment that we're going to have problems with that. But I guarantee you out there on your PLCs, they're all going to be connected to what? They're always going to have the ground pin. And the ground pin, the ground connection is going to be different than the other connections. And it's up to you. You want to make the blue reference ground, or you want to make the red reference ground. It's up to you. Does that make sense? So what I got to do is I've got to bring him up to this guy right here. And we're going to do that through the cables. So those are available to us through the cables that we're going to wire down here. So they got to send minus down here anyway. So if we got to send minus down there, then we can use those too. Does that make sense? And then of course, this guy here's got 1, 2, 3. It's got 8 plus 6. It's got 14 inputs, and then it's got I think 10 outputs, which is more than we need. I mean, it's not enough that we need, so we're gonna have to use some of these over here on this IO module. Are we okay? Yes, so?
It's still breaking up.
I don't know what to do.
I know. I'm hanging with you.
Okay. So the cables that we're going to use, I'm going to go ahead and pull the module out. This is the top. Now what this top does right here is it kills power to the output. We have to enable that. I don't know if it's enabled on this or not. But it doesn't tell the PLC that it's got an e-stop. So when you was doing your looking at your diagram, by the way, I think I only got 3 tag cables. I looked at Blackboard lately, and they were due before class. Right? So.
Wait, I sent mine in an email. Is that okay?
Yeah, that's fine. Yeah, I got your.
I did too.
Yeah, I sent mine an email.
Yeah, I know I got Kristen's, I know I got James's, and I got Capri's, and I got Tyler's.
Rich, I did mine on the message.
I got it. That's
Okay.
fine. In fact, me, it's a little better. What you got to get used to doing, guys, don't use the default name on there. What do you need to? You need to change the title and put your name up there, right? And also put the station that the tag is for. So I think that was on there. But when you save the file, you need to change the name instead of the tag table, because I'm storing this in a folder and I'm having to go out there and rename all those depending on the So this one looks like it was wired up before. Somehow this guy's thing loose. I think I'm gonna have to have like it might be an Allen wrench. So these are the cables that we're gonna wire up to the PLC. Oh, y'all don't see what I'm doing, right? Sorry.
And I was like, what's going on?
So these are the cables that wire up to the PLC. So we'll figure that out, how this thing wires up. All these ribbon cables, we call them flat cables. See how they get one
He records.
on there.
Yeah.
It's the ribbon cable. Notice got this nice red stripe down here. This identifies pin 1, and it'll go right down the line. So pin 1 would be right in here, one of these, and then it goes right down the line. This is 10. That'd be, this would go to pin 1, this one would go to pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8, pin 9, pin 10. We'll look at the wiring of this. So we got to know that because the actual connector keys. Let me get my hand out of the way. Let me see that. Can you see this guy right here? It sticks out a little bit. So what that means is when you put it in the connector, if you look at the connector, it's got an open slot on one side. Like right here. Still hard to see. Got an open slot on one side. So when you put the connector in there, you're going to turn the slot. Tab right here is going to turn toward that slot, and then it'll slide in right there. Of course, we'll have to figure out which one that we're going to use. We're going to use these, and we're not going to use these. But okay, I'm gonna have to get a tighten that down. Somehow it came loose, so let me pause the lecture and do that before this thing breaks on me. I couldn't hear anything, Michael, because I wasn't saying anything. So we're going to use these two here and these two here. We'll look and see how this thing's supposed to wire up. We'll wire our PLC before we mount it. Because once you mount it, it's real hard to get in here. So what we'll do is we'll wire the ribbon cable. Can y'all hear me?
Is there?
Yeah.
So what we'll do, we'll wire the ribbon here. That's all we'll have to do when we mount it on the PLC. You just run them down through the slot. So it's a lot easier to wire the PLC. We'll take the cord off to the flat door, wire it that way. So let me bring up, hopefully the PowerPoint out there. This came from Festo, so I'll put this up there for you. I just noticed that it wasn't up there. So this is the connector that's going to connect our edge trainer up to the MPS, the Festo MPS line. And the wiring, what's neat is the wiring is exactly the same for all the modules. So if you saw how to wire one, then you can wire all 7 of them. So this is SD1, SD3, this is SD4, this is SD5, and then this right here is SD6. So the ones we're going to be looking at is these two right here, and these two right here. One of them is going to be input, one of them is going to be output. One of them is going to take us up to the control panel. The other one is going to take us up to the actual line itself. Now this is the actual wiring. So pin 1 is going to be what? Coming from the edge trainer, it's going to be, see that?
24 volts.
24 volts. It's going to be input 0, input 1, input 2, input 3, input 4, input 5, input 6, input 7, and then pin 10 is 0 volts. And this would be the way we would wire what? SD5. This SD6, this is going to be 24 volts. It's going to be Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. So all we basically got to do, guys, is all we got to do is take one of these cables. Our cable that's I've already got this out.
L2 plus stand for 24 volts, or what's that stand for?
It's L2. L is 24 volts. M is 0 volts, just for reference that, so, or minus. So L.
Okay.
All L's are.
Oh yeah, L's. Yeah, I remember L's positive. Yeah, okay.
So what I'm going to do is I'm going to take this red wire, the one with the red stripe, and of course, what can I find? My screwdriver, so it's down here in the floor. Since we had the trainer in here, I'm going to come back and make sure these are all backed out. So I'm going to come up here and take 10. Why am I going to take 10? So here's 10 right here, all the way on the very end. And I'm going to put it in the, I understand why.
Because wait, no. Now,
Let me go back to my PowerPoint. I don't know if I'm going to be able to do it that way. Let's see if I can do it this way. So what I need to do, we'll probably do that. So the problem is that this guy right here is not currently up there. And that's what I was doing during the break. And I don't know why. What I'll do on the break is I'll upload this so y'all can go to course content and go between the two and look at them. Because I'm doing an input. We're running syncing input. So if these are inputs, I'm not going to use this guy because the syncing input, I'm going to use what? I'm going to use 0 as the common. Y'all understand that? Yes.
Yes. So that's why it's on. That's why you use 10. Okay, I got it.
So that's why when I was looking at this and I saw M for my inputs, I took this wire right here. I took pin 10, and then I ran it into M. So that sets my inputs up to be syncing, right? If I'd have run the plus over there, nothing would have worked because this PLC runs syncing inputs. Now all I have to do is
So does that,
I'm going to ignore this guy for a while. I'll have to use it sooner or later. And then I'm just going to come right down the line, right? Then after my M, I'm going to put what? I'm going to put input 0, input 1, input 2, input 3, input 4, input 5, input 6, input 7. So all I have to do,
you start with 10, then you go to 2, and then
yeah,
go from there.
so what I'll do when I go back to my camera, like I said, I'll upload this so y'all can actually see it. So when I go back to my camera, I'm going to take pin 2, which is this guy right here. This is pin 2, because the red is what pin? It's pin 1.
One.
This is pin 2, and I'm going to wire it up to input 1. And then I'm going to take pin 3. You got to keep these things from crossing, guys. Then I'm going to take 3, and I'm going to hook it up here to input 2, right? And then I'm going to take 4 and hook it up to input 3. And when you got this down, I mean, once you get the sequence down, usually it's really, really easy to hook a PLC up. So what we're going to do is we're going to use the same EduTrainers that we used for PLC 3. We're going to use that for our PLC class. So we're going to go ahead and wire up the PLCs, and then all we're going to have to do is just swap them out. Does that make sense? And then, of course, y'all will have to rewire these. So what pin am I on? I think I'm on pin 5. We go to input 4.
It's got to be a bit tedious to get them to keep from being all jumbled together.
Yeah, it is for these. So what you do is you just spread them out, and when you come up here and you find them, what you do is you just go ahead and route it out, right? So here this be this one. And you're right; it's hard to keep them from getting jumbled up. And, now, what I've been thinking about doing, but I just hadn't had the time, is actually building a box where we could plug this thing up and see if it was wiring correctly before we put it up, before we actually connected it to the line. But I think we can actually hook it over to the inputs over here and see if it's wired correctly. Am I going to make a mistake? Maybe. We'll just have to double check our work and make sure I don't. So that should be input 8. All right, guys, you'll take a few minutes break. Okay?
All right.
If y'all are not breaking already. So what we're going to do now is we're going to go over, if I can get my PowerPoint together. So we've done these inputs right here, right?
Yes.
What we're going to do now is jump over here for the S. So we did S5. So now we're going to do S1. Now we don't need 24 volts because we already have, the inputs don't use 24 volts. We don't need 0 volts because we already have it connected over here, right? That makes sense? So all we have now, I'm going to start off with pin 2 on my second cable because we've only got 10 cable, or 10 on there. I'm going to start off with pin 2 on my second cable and start wiring that. Here's my cable. Here's the red wire. This is pretty common, guys, on ribbon cables where they'll, I've seen them use blue sometimes, and of course this guy's using red. And this identifies the pin 1 side, and then they're just numbered right down the line, right? I'm going to take this guy right here. This is 2. And then I'm going to hook it up to 0 on the second byte. And then I'm going to take 3 and hook it up to 1 on the second byte. I know y'all really messing out on this, guys, so wiring a PLC is a lot easier than wiring a relay logic circuit. So I'm just coming right down the line, right?
In the second byte, it only has like 8 or 6 or 8, doesn't it? Or
Yeah, but what are we going to do when we run out?
Stop wiring? I don't know.
So we're going to jump over here to this module right here.
Oh, okay.
And this is addressed, this is addressed as byte 8. Now what we're going to do, if we look at this, we have to bring plus and minus over here. So what we'll do is we'll use the plus and minus off the cable where I'm going to get up here so you can see. So here's L right here, if y'all can see it. Here's L and here's M. But we'll just bring it over from this cable that we're wiring right now.
Okay, so then we'll actually end up using 110
We're going to use,
on the other one.
yeah. Where am I at? Y'all gonna make me lose my count. And we will double check this when we get it wired up. But don't be afraid to ask questions. Even if I do screw it up, trying to answer your questions, it's nothing we can't fix.
Yeah.
So when you did your tag cable, it went over to 8, which would be this guy right here. So what we're going to do here, though, is we're going to take the plus, which is this guy right here, and we're going to wire it right here.
Into L. Wait, no,
L.
yeah, L.
And L. And then I'm going to take 10, which we know on this wire is minus, and I'm going to wire it into the M.
Can you scoot it down a little bit? We can't see that part. Yeah. Okay, cool.
Okay. So then we'll take the one we left off on. I think we got 2 left, right?
I believe so, yeah.
Now, what we will do is normally on regular PLCs, we would, once we got this all wired up, we would use wire ties and everything. I did it again. You see what I'm doing?
You pull one out?
Huh? No,
Or
I'll
you pull
have to
something
pull it
out?
out later. I'm wiring them around the cord for my camera. I'm running it.
Oh,
I'll take care of that later, guys. So we got that. We're through with our inputs, right? That's all the inputs we have that we're going to wire. So we wired this 1 through 0 here. I'm sorry, 1 through 7 here, or 0 through 7. And we wired this 0 through 7 here. So what are we ready to move over? And now this takes us up to, now notice this goes in bytes because this is a Siemens PLC, right? And this would be input 0, 1, 2, 3, 4, 5, 6, 7. This would be input 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. So we've moved over to the second byte. Everybody okay?
yes, sir.
Any questions? So
No, but you only hooked up 2 wires on that side. How you get
yeah, that's all.
7 out of that?
But we had to do that because the actual Festo line requires 16 inputs. Well, when we bought the 1200 PLC, so we got the 1200 PLCs, guys. They sell them as 6-packs, and when we bought them, since we were a college, we got the PLC, we got the Titapor software, we got the little simulation box that goes in the top, and then we got an analog signal card that plugs in here, which we Siemens don't use it. So what's nice is if you want to, and it's very very small, they've got this slot right here without putting something on the slide, and you can buy different cards to go into here. So they gave us an analog signal card, they gave us the software, they gave us the PLC for about $350. So all we had to do to adapt it to the Siemens over to the Festo line is just buy this right here. Just additional I/O card. I mean, I'm sorry, this is additional I/O module. I don't know how much we pay for that, but it would have been. It's still cheaper than for us buying a Siemens PLC, which they wouldn't give it away as an educational discount. It would have been a lot cheaper to buy a PLC that would do that. You know, does that make sense? So yeah.
Yes, sir.
But
I got you.
it seems like we're wasting them, but we still saved a ton of money by doing it this way. So I understand. So yeah, we're only using 2 of the inputs on this guy. We're using these 2 right here.
Right. Okay.
And these 2 right here are power. Now we're going to use more outputs down here because we've only got 10 outputs. And this calls for wiring up what? 16 outputs. So we should have plenty. We got 10 over there. And so what we'll do is we'll use 6 of these over here. That makes sense?
I got you.
Yeah.
Yes, I'm with you. Yeah.
So you can buy the module for exactly the extra ones you need, which works out good because if I ever wanted to add something, then I've got these inputs and these outputs available, right?
Right.
So what we need on our outputs, if I look at my PLC, let's bring my camera back up and let's look at the output. And let's get a little closer to it so we can look, and I'll raise it back up when we wire it. So we got to bring an L over here. We got to bring an M over here, right? And then over here, all we need to bring is a nothing, because it powers up. It's going to power up from up here, the ones we wired. But we do have to bring an L and M. We do have to bring. I'm pointing at my screen. I know y'all can't see that, guys. We have to bring in a what? We have to bring in an L, 24 volt. We have to bring in an M. So we'll do that with our first cable. So here's the red stripe one. So this is the L. I'm gonna have to raise my camera back up, guys. I can't see. Let's see if I can leave it down pretty low so you can see it better. I'm gonna bring in my L. No, that ain't gonna work. Yeah, when I get through, I'll just unhook my camera, but I can't unhook my camera now because we'll lose it. So, and then I'll just pull it out. I'm not gonna pull the wires out of the PLC. So there's my L. And then I'm gonna come over here and get wire 10. And then I'll hook it up to my M. And now we just start going straight down the cable, right? So here's the one right beside the red. So this is 0. This is wire 2, which goes to 1. This is wire 3. That goes to 2. Wire 4. That goes to 3. Wire. I think this is the last one. This should be 7 right here. Short one.
So for the outputs, they're going to end up using all of both wires except for the L and M on the second wire, right?
Yeah, we'll use all the wires in this cable, but when we hook the other set of cables, we'll have to tape up. We'll have to tape up the
L and M,
yeah,
1 and 2. I mean 1 and 10.
yeah. We'll have to tape those up because they're not going to be used on the second set, right?
Right.
It makes sense.
No L and M on the second one, right?
Yeah. So there's no L and M over here because we powered this up here, right? So notice there's no L and M. I'm gonna look down at the second set. Try to get as close as I can. The camera's doing a really good job tonight. So this one is this one. So this would be input 0. So these are not connected. So that means we're not going to use this one, and this one. And then it's going to go 0, 1, 2, 3, 4, 5, 6, 7. But we're not going to use, we don't have to bring L and M over here because it's already connected up at the top, right? You understand that?
Yes.
So here's our second cable. So we're not going to use, here's our last cable to wire up our PLC. I need to raise my camera back up so I can get the hand in there. So here's my last cable. So we're not going to use pin 1. So what we'll do is we'll come up and we'll put a piece of black electrician's tape over here. And we're not going to use 0. So we'll put a piece of black electrician's tape on this guy. Now we'll just go right down the line, right?
Right.
So I'm going to skip over the first.
They're not still.
See the dots? I'm going to skip over the first 3, and I'm going to come right here.
Oops, internet dropped a second.
Mine or yours? We still hear you.
Mine, it cut out. Are there not still any more outputs on the PLC on the original part?
Yeah, there is. This is the one that goes there. I'm sorry. Thank you. Thank you, Tyler.
Yeah, that's what I was thinking. I was like, isn't there a couple more? I think
1.
one.
Yeah. Well, no, there's 2. I'm sorry. You're right, because there's we had 8. We got 10 outputs.
I got 8. Okay.
So this one goes here. That's why it's always nice to have 2 eyes or 2 people taking care of each other. And
Yeah, I remembered you said there was 10 on the first part, so I was like, we only did 8, so I was like, there has to be 2 more.
right. We'll skip over the first 3, 1, 2, 3, and then go to this guy. Oh, that's a little better, ain't it?
Yeah, it zoomed in a little. It got a little bit blurrier, but it's still, you can see better at the same time. I know that sounds weird.
Yeah.
And we skip over the first 3 down here also.
What are the first 3, 4 on those?
It's just that when you buy these terminal blocks right here come in standard sizes.
Oh, okay.
Yeah. So you can't really split them up. If they made them for you special, then that means you would pay a lot more for them. And so what they do is they use these same terminal blocks on more things than just this PLC. So if they buy them in mass quantities, of course, they're going to save a lot of money, right? So 1, 3, 4, 5, 6, 7. So I'm missing one somewhere. So we had 2 over here. 1, 2, 3, 4, 5, 6, 7, 8. So we're wired up. So what I'll do is I'm gonna get a piece of black tape and I'm gonna tape up the plus and I'm gonna tape up the minus. Then what we can do next class, I think this will work, is to verify our wiring instead of hooking it up over to here. Instead of hooking it up over to this guy, what we can do is we can hook it up over to these guys. And then that'll give us a method of verifying our trainers. So see, this guy here's got 16 inputs. And we should be able to go right down the line, right? And then we got 16 outputs. If I wired into the outputs and wired into the inputs, then we should be able to verify our wiring by using the trainer itself. But we'll have to write a program. We'll write a program to verify the output. So like we'll take switch 0 and then have it bring in an output that turns on output 0. So when we get this thing set up, we'll write a program to verify it, and if it verifies okay, then we'll just move the connectors over to this guy. And if it don't verify, then we'll rewire it and figure out what we did wrong. You need to try to verify it. Of course, a lot of PLCs, it's a lot easier to do than using ribbon cable because you're dealing with one wire at a time. So it's a little harder to make mistakes on that, but you still make them. So there should be a way you do that, simply by just taking an ohm meter. Let me get it out here. Just taking an ohm meter and hooking up to the terminal block where this guy's supposed to go to and ohm it out before you fire this thing up. Because if it's not wired right, if you got an output wired wrong, and if it turns on, it might turn on a clamp or something and kill somebody, right? So it's always a good idea to ohm out this thing, ohm it out. We're gonna let the trainer ohm it out for us. It'll be a little better. And still have a few people that did not turn in their tag table, guys. I'm gonna give y'all to, and I don't know. I know Josh is not here. I guess I'll have to send him a text. Everybody's here but Josh. And these are actually labs that y'all are getting credit for. So right now we've got this will be the 4th lab right here. We ran the Festo line manually, right? Then we did what? Then we got an introduction to the TIA portal. We ran the Festo line manually before they put us out. Then the tag table that y'all submit, that's lab number 3. And then, of course, wiring the PLC, y'all get credit for that, the ones that are here. So Josh wasn't here tonight, so he won't get credit for this now. So that's the only way I know how to do it. So any questions?
No.
You didn't get mine?
I don't know if it came through. How did you send it, Michael?